Great, guys. Any questions over the assignments? Any questions over any of the assignments we have done thus far? Now,
Wait, I do have a question about this one.
okay,
On this, I put like -1.
because it's wanting the function.
Oh, so I have to like rewrite the whole thing.
Well, we just need to drop the parentheses here, which would be x plus 4 minus 5.
Okay.
Mm-hmm.
So just spin it right.
Yep. Yeah, because the function x minus 1 here graphically would look something like this here. For just -1,
Okay, yeah.
it's talking about this here. So it's a little bit different,
Yeah.
but we won't have much of any of that show up again.
Yeah, I was just curious.
Yeah. No, if you have questions, please ask. Now, what we're talking about today in this section here is called focus on a parabola. So we're mainly looking at this here, and it has a focus. A focus is the center, a center point on a parabola, and it's very useful, especially in any kind of disc type shape device. So if you have a satellite dish to get TV or kind of really TV, they will use this parabola and set it up so it's focusing into a point to direct out or to receive information in. And it works out that the distance from what we call here the focus point to its equivalent spot on the parabola or on the satellite dish itself are equal. So this point here and this point here actually would have the same distance to that point, because it is the focus point. It's the focal point for that there. Now, there is another one they talk about. So we have this here. We have the focus. We also have the vertex, the center or kind of the lowest point on this parabola. Now we also have another line down here called the directrix. And it's perpendicular to the axis of symmetry and is the same distance away from the vertex that the focus is as well. So these are kind of some of the key details. Now, there's a method that we could go through using the directrix in these links here to actually find out what the equation is. But we're not going to deal too much into that or go through the process of finding that. Any questions on this so far? Now there is a set equation line that goes straight across here and here to where it's in the dead center going straight across, kind of perpendicular that way. And if I remember correctly, we called this here the length of the lattice rectum. I don't know why, but there you have it. Now there's 4 different ways that we can draw or create this parabola, but only 2 main ones that we focus on. Because the first 2, it's either opening up or down. The only other 2, it's either going to open to the left or to the all you're doing is matching it up to an equation. Which one does it match with? Which one has a square connected? What's squared in the first one? What's the power for y? Exponent. Exponent for y. Is there one? So it is understood to be 1. What's anything to the first power? Yeah, 6 to the first power is just 6. So if it's not written, it's understood to be. So y is to the first power, x is to the. That's If x is squared, this is the type of formula we're looking at. If y is squared, this is the type of formula. It's up and down if x is squared. It's left and right if y is squared.
Makes more sense.
So x is equal to 1 over 4p, or y is equal to x over 1 over 4p times x squared. Now the focus is the point 0, comma p. The focus for our first one is 0, comma p. And the directrix is y equals p. Y is equal to negative p. So when we have the equation y equals 1 over 4p times x squared, the focus is 0p. The directrix is y equals negative p. And the axis of symmetry is x is equal to 0. P is going to be the number that's right in front of the x squared. So 1 over 4p is where the p is located. Now when the y is squared, our focus is p comma 0. Our directrix is x is equal to negative p. And the axis of symmetry so if p is greater than 0, it's going to open up. If p is less than 0, it's going to open down. Really what that's saying is p, because what values are greater than 0? They're going to be positive. So if the value of p is positive, it's opening up. If it's negative, it opens down. Because up is kind of the positive direction, down is the negative. With left and right, which direction is positive? The right. So if it's positive, it opens to the right. If it's negative, it opens to the left. Let's look at the first example. Identify the focus, directrix, and axis of symmetry. We're not graphing. We're identifying the focus, directrix, and axis of symmetry. What variable is being squared? The y is being squared, yes? So looking back to our general equation, the one that has y squared tells me that the focus is t comma 0. The directrix is x is equal to negative p. And the axis of symmetry is y equals 0. So that's not complete because, again, we need to actually find the value of p. But on a test, you've got 1/2, 2 points out of the total. You have the correct equation for the directrix, x equals and not y equals. Axis of symmetry, y equals 0. That's finished. Nothing else we need to do there. And we have half the focus because we've got comma 0, because it has to be comma 0. Questions on this so far? Now, what is the general equation for this here? X is equal to 1 over 4p times y squared. This is the general form. Is the equation that they gave us in this form? Because what did they give us? Negative 4x equals y squared. The general form has what? X by its, okay. Get it into that form. What do we need to do? Divide both sides by negative 4. Which will tell us that we have x by itself is equal to y squared over negative 4. Are these the same? Because if I multiply negative 1/4 by y squared, what do I get? So the y squared would go where? On top, yes? What's 2 times 1/4? Well, it would be 2/4, yes, because we multiply on top. So this here, I can move the y over, because negative 1/4 times y squared is the same as y squared over 4. Yes? Because it's just moving where it's at. Any questions on any of this here? Because the main reason we move it over is to get it to look like this. Because I want that number times y squared. Any questions on how we got to this here? Any questions on how we got to this here? We good with this here so far? Where is the p-value in this here? With the 4, it's right here in the fraction, yes? That's where p is located. What's located in that spot in our function? This right here, yes? This is in this place, yes? So where's the p located? It's in here, yes? Which means the p is located where? So what's our equation state? Not just p, but 1 over 4p, yes? Because that's in the general equation and it matches up with what? Negative 1/4. So we're saying that this here is equal to, because all we're having to do is solve. We need to get it in that form to find out what is taking the place of 1 over 4p. We're going to set them equal to each other and solve. Questions on this here so far? Now, once we get the equation in the correct form and get this set up, the first step is always going to be the same. We're going to multiply both sides by 4p. Once we get the equation in the correct form and we set up the 1 over 4p with whatever's in front of that term squared, the first step is always going to be to multiply both sides by 4p. Because on the left-hand side, I'll go ahead and write this out the first time. We're going to get 4p over 4p. And on the left-hand side, we have negative 4p over 4. What is anything that's divided by itself? 1. So the 4p over 4p is? What about on the right-hand side? Because the 4 divided by 4 would be 1, yes? Which does leave us with p, but it would be negative p. Questions on this here so far? Is p by itself? No, it has what, a? So we can multiply or divide both sides by negative 1, which tells us p is equal to negative 1, because negative p is equal to 1, so p is equal to negative 1. Yeah, you can go. Questions on how we found the value of P? We good with finding the value of P? Plug it back in. So the focus is -1, 0. We're replacing P with its value. And the directrix, x is equal to what? -P. Because we would plug it in as, I want to write it out, because it would be -1, which is just 1. So x is equal to 1. And that's it. So the main thing we need, depending on the setup, yes, that form, because also it's not away from 0. Because all the ones that we have for this here, the vertex is going to be the point 0, 0. Yes, and I'll include that here because the vertex for both of these here is the point 0, 0. So here, we kind of skimmed over it, but the vertex is at the origin. It's at 0, 0. All right, let's look at another one of these here. Identify the focus, directrix, and axis of symmetry for this one here. Now looking at this equation, so we have -2x equals y squared. So which variable is being squared? So if we look at the general equation for this here, we're looking at x equals 1 over 4p y squared. Well, it tells us that the focus is the point p comma 0. Our directrix is the equation x is equal to -p. And the axis of symmetry is the equation y is equal to 0. And again, all of these are based off the fact that the vertex is the point 0, 0. Well, we already have the axis of symmetry done. Now we just need to find the focus and the directrix, half of the focus and the directrix. Is this equation that they gave us set up in standard form? No, the x is not by itself. So to get it into standard form so that we can find the value of p, we need to get x by itself. So what do we need to do first to get x by itself? We need to divide both sides by -2. And if we divide both sides by -2, we do get x by itself is equal to, well, we have negative y squared over 2. Or, a little bit nicer way to write this, 1 over 2 times y squared. We can move that y squared out to the side. If there was a number up there with it, so if it had been 2 or 3y squared, we can move the y squared over and just be -3/2. Because -3y squared over 2 can be rewritten as -3/2 times y squared. These are the same thing. And again, we're doing this to find out what the value of p is. Any questions on how we got the equation in the standard form? So looking at this here, P is located in that fraction in front of y squared. Well, what's our fraction or the number in front of y squared here? Negative 1/2. So what we're saying is if we want to find the value of P, our 1 over 4P, we need to set it equal to negative 1/2 because that is the location where P is in this equation. Questions on this so far? Now at this point here, we need to do the same thing we did on the last one. We got to multiply both sides by what? 4P. Because on the left-hand side, well, 4P times 1 over 4P is 1. 4P times 1 over 4P is going to be 1. Now the right-hand side, we'll get negative 4P over 2. Well, 4 over 2 reduces to 2P. 4 divided by 2 is 2. So we have 1 is equal to negative 2P. Is P by itself. So what do we need to do? Divide both sides by negative 2. Which tells us P is equal to what? Negative 1/2. Okay.
Where is the 4P? Is that like the basic equation that you use for everything?
Mm-hmm. Yep. Yeah, so we just got the fact that the general equation, I'll scroll back down, is this here.
Okay, so that's the equation that's the general equation.
Yes, for these here.
Okay.
Now we got our equation back into standard form. Well, we can look at it more in this way. Negative 1/2 y times y squared. So what's in the place of where 1 over 4P should be? Negative 1/2. So whatever value P, when plugged in, will get us this here. So to find it, we set negative 1/2 equal to 1 over 4P. We multiplied by 4P to get those two to cancel out and then solved. So the value P is negative 1/2. Yes. Questions on this here? Now the last thing we have to do is plug it back in for the focus and directrix. Now the focus is just going to be negative 1/2 comma 0. I'd keep them as fraction if we already have it as a fraction. Yeah, if we already have it as a fraction, might as well leave it as a fraction. It could be a decimal. There's nothing restricting it to be a fraction. But especially once we got down here negative 1 or 1 divided by negative 2, negative 1/2. We can kind of leave it as that there. Even if it's improper fraction, so it came out to say, I'm just circling negative 3/2 because it's sitting there. If P turned out to be negative 3/2, we can leave it as that. We don't have to rewrite it as negative 1.5. Now the other part is the directrix. Directrix, so here x equals negative P. So it's equals, it'd be positive 1/2. That's it. Questions on this here? We ready for the next one? So here's a fraction. Y is to, or x is equal to 0.5, sorry, I had it right the first time. Y is equal to 0.5 x squared. Yes? So it's already in the right form, and this time instead of y being squared, we have x. So looking back to the general form, the focus this time is the point 0, comma, p. Our directrix is the equation y is equal to negative p. And our axis of symmetry is x is equal to 0. And yes, this one's already in the correct form because the x, or here, in this case, the y is by itself. We have a number in front of x squared, yes? So, what's matching up to our 1 over 4p? The 0.5, yes? So what we're saying is that 1 over 4p is equal to 0.5. It doesn't matter that the other side's not a fraction. It'll still work the same way. And in the other ones, what did we do first? We multiplied both sides by what? 4p. And the reason we did this was because here the 4p and 4p would cancel, leaving us with 1. Now we're doing 0.5 times 4. Or so 0.5 is the same as a half, yes? What's half of 4? We can also do that in a calculator, 0.5 times 4. What do we need to do next? Divide both sides by 2, telling us p is now the focus this time is going to be 0, comma 1/2. We're just replacing p with its value.
So you didn't have to do that equation since we already know that it's 1/2.
0.5, it works, I mean, incidentally, it does work out that it is 1/2. But it's,
It won't be like that.
especially when the numerator is not 1 for our p value, because if the p value was, say, 2, the equation would look something like this here. Or if we said that the p value was 1/8, because that'd be this here. Or not 4, because 1/8 would be 4, this would actually be 2. So they work differently. It incidentally works out that 1/2 gets up 1/2, because 4 times 1/2 is 2, so it stays on bottom. Now the last thing we need is the directrix, so y is equal to negative 1/2. And again, this is with the vertex being at the point 0, 0.
So with the axis of symmetry, it's always going to be here.
For these here, yes, when the vertex is at the point 0, 0. We can. But really, and it's still, because what have we done so far? We're just matching up what is where, right? Because it's what is taking this value's place, what's taking this value's place. And that's really it. We're not doing any huge calculations or figuring this out. It's looking at this, how does this equation match up with this one, plug in the corresponding information. And that's really as difficult as this gets. Even when we move it away from the vertex of 0, 0, we're just plugging in h and k. H and k are just taking a different place. Questions on this here? Let's look at this one. Negative y equals x squared. So which one's squared? x, which tells us that the focus is the directrix is y equals negative p. And our axis of symmetry is x is equal to 0. In the general form, y is equal to 1 over 4p x squared. Is our starting equation in the correct form? What's wrong with it? Negative y. We need the y to be, well, we can either divide both sides by negative 1, or we can multiply both sides by negative 1. Because if we divide both sides by negative 1, we'll get negative, or y is equal to negative x squared. Yeah. Because what's the number in front of x squared? Negative what? Negative 1. So the number in front of our x squared is negative 1. And it's taking the place of what? 1 over questions on this so far? Yep, first step, multiply both sides by 4p. Because here the 4p and 4p will cancel, giving us 1 is equal to negative 4p. Now what can we do? Both sides by negative 4. Telling us p is equal to plug it back in. So our focus is going to be the point what? 0, comma, negative 1/4. The directrix is y is equal to 1/4. Questions on this here? So, looking at this one here, which one is squared? So the y squared, yes? So the focus is going to be the point p, comma, 0. I mean, at this point, we don't have to write p anymore. We know that we're solving for that and plugging it back in. The directrix is going to be the equation y is equal to negative p. I'll still put the negative in there, even though we're going to plug a value in, because it's good to put that negative there just to remind ourselves whatever that value is will be negative, or we're going to have to flip it from the focus. And our axis of symmetry is going to be the point or equation x is equal to 0. And we know the vertex for these here are 0, 0. And this is matching up to our equation x is equal to 1 over 4p times y squared. So we could flip, so 6x equals y squared like this here, yes? So it's the x by itself. Yeah. But what are we going to need to do? Divide both sides by 6, which really will give us x by itself, yes? And on the other side, we could rewrite it as 1/6 y squared. because that's the same as y squared over 6. We're just moving the y squared over. Does that kind of make sense of what we did? I mean, realistically, we could say I'm multiplying both sides by 1/6, because 1/6 times 6 is 6 over 6, which does reduce to 1. Multiplying by the reciprocal. So what's our 1 over 6 matching up with? The 1 over 4p. So 1 over 4p is equal to 1/6. And again, what do we do first? 4. We do multiply by the 4, but also by the p, because those will cancel out. So we're doing 1/6 times 4p, yes? 4p over 6.
Would we ever reduce these?
Yeah, we can reduce it. No, I mean, you're going to need to reduce at some point. Because 4 over 6 reduces to 2p over 3. Because we could have typed 4 times 1/6. We could have typed that in a calculator and it would have told us that it's 2/3. So 2p over 3. What can we do next to get p by itself? By? Over? Because we could have divided both sides by 2/3, or we could multiply both sides by 3/2. Because over here, because we'd multiply straight across, 2 times 3 is p. On bottom, 2 times 3 is 6 divided by 6 is 1, which leaves us with p. P is 3/2. Because if we have a fraction, we can always multiply it by its reciprocal. So 1/6, its reciprocal is just 6 over 1. So the focus is 3/2. The direct 6, so y equals negative 3/2. Since it's not negative, the sign will stay negative. As if it had been negative 3/2, y equals negative 3/2, they would cancel it out. But that's it. And that's your answer.